we are going to do another question, which is the sum and difference, the sum and difference of two vectors are equal so that are equal so that um, they are they are perpendicular to each other. So prove it. So I think we must prove that when we're talking about equal, I think it's talking about the magnitude. So this equal right over here, um, this equal might not be the best word, but this equal in terms of magnitude. So let's just be sure. So the sum and the difference must be equal in magnitude, and they also must be perpendicular. So to be equal, so the sum and difference of two vectors are equal if, so let's change the question to make it sound better. So the sum and difference of two vectors are equal if they are perpendicular to each other. So prove that. So we need to prove this. So, and I think this is pretty easy to prove as well. Since we know that the magnitude is going to be equal, let's just say the magnitude is going to be equal. And let's say the vectors are, so let's say vector is vector A and vector B. So we have that the magnitude of sum and the magnitude of difference is going to be equal, right? So now let's just use the formula. The formula is square root of a square plus b square plus 2ab cos theta, and the formula of a minus the formula of vector subtraction is going to be a square plus b square minus 2ab cos theta. Let's add this over it. Now if we square both sides, the square root symbol is gonna go out, and we will have a square plus b square plus 2ab cos theta being equal to a square plus b square minus 2ab cos theta. Also, the a square, this a square and this a square is going to cancel each other out. More accurately, we are subtracting a square from both sides, but cancelling out is not the same, but it works out in this case. So we have this, right? Now we just need to move over here and there. So this is a minus sign, so it's going to be over here plus, so it's going to be 4ab cos theta. And if the magnitude of a and b is not 0, so we can divide everything by 4ab. So we're dividing everything by 4ab since the magnitude of a and b is not 0. So if it's not 0, then we have the angle to be 0, so it's going to be cos 90 degrees, which means the angle theta is going to be 90 degrees. So we proved it, right? So the question was, if the magnitude of addition, the sum and difference is equal, then prove that the angle between them is going to be 90 degrees. Okay, so let's just see how this is. So let's just take any two vectors. Let's take a simple case. So I'm going to take this two vectors. So let's make this a white vector. Let's make it a lot more thicker, right? And let's take another vector. So this is going to be another vector. I'm making both of them 2 units to make it much more easier for me. So if you have this, right? So let's say if we have this, then we will obviously have now the resultant for the first case, which was sum. So if we do vector addition, it's gonna be, okay, sorry, let's try this from here, here. Let's also make that dotted line. So the magnitude of e plus b is gonna be this, right? So this is gonna be magnitude of e plus b. Let's make it red, and let's write this resultant is vector addition of vector A plus vector B. This is vector, sorry, this is vector A, this is vector B, and this is 90 degrees. So that's the key point. So this must be 90 degrees. That's what we prove. Now I'm going to take this vector and I'm going to flip it around. So to flip that around, let's use this. So we flipped it around. So this is going to be minus B vector. Let's make this that color, and this is minus B vector. And also let's copy this and flip it. So like that. Let's keep it right over there. Let's take this and let's move that as well. So like this. So this is gonna be the second resultant. So this resultant is equal to vector A minus vector B, right? But is this the only way to do this? Of course not. You can also take vector A and make it you can rotate this to make it like that, so that I will also change the color in a bit to make it much more cleaner, because I think it might be a little bit difficult to look. If I'm explaining it to you, I don't think it's going to be that difficult, but if I don't, I think this is going to be pretty difficult to understand what I'm trying to say. So that's why I'm going to make it a little bit much more understandable. So first of all, let's make it a little bit more pretty. Then we will talk about what we are talking about. This is going to be minus A vector, right? So let's make this as orange, this as this color, because why not, this as dark red, and this as this brown. So we have different colors, and this vector, so this resultant is gonna be vector B minus vector A. So as you can see, the length of all the resultants are actually equal, right? So they are equal because this is at 90 degrees. We just look at the example, but this will be valid in every single case. So you can make it so that this vector is longer, this vector is shorter, the other vector is longer, the other vector is shorter, and it will work out. You can try that in your own time, but I'm just going to show this most simplest case that I could think of, since I don't want to make a lot of them. So just think about it. If we increase the size of this, the size of this will also increase like that, which means it's going to increase like this. So actually I can show it to you. Yeah, it's not that. So as you can see, even if there is 90 degrees, everything is going to line up. So I think it will be better if I make it different sizes, right? Since it's going to be valid in any case. So we have this case. So let's put this case over here. So let's show you another case. And another case was going to be the simplest case, this case that I initially wanted to do. So actually let's move this to be aligned to this, and now let's look into this. So let's move it down. This will also be moved down. So as you can see, the resultants is always going to be the resultants are going to be equal to each other no matter how we do this. So and this will, the sum and the difference is going to be equal only when this is 90 degrees. So you can try other angles, the other angles will never give you equal. You can do this in your own time. And as you can also see, if the lengths of the magnitudes of vector A and vector B are equal, you will also see that this is going to be 90 degree as well. But that's not important to our question, and we are not going to talk about that. So this is our example 1. So example 1, this is our example 2. So this is going to be it for today's video. In the next video, we are going to do another question. So until then, bye bye.